Before getting into sigmoid function, let's understand the intuition behind a logistic regression. We know that in linear regression, we use a formula something like a y is equal to mx plus c. And why can't we use the same formula for the logistic regression, right? So that's where the sigmoid function will comes into a picture. We'll talk about that. So here the intuition behind logistic regression. So here we try to classify the labels or a class, right? We are trying to understand which class a particular data belongs to. So when I say binary classification, it's like either 0 or a 1 I'm going to predict, or maybe pass or a fail, right? A black or a white. So this is basically my binary classification, right? So how do I decide that any particular point is basically 0 class and some other points are belongs to 1 class? So that's where the sigmoid function will comes into a picture, and this will assure us that the percentage of a 0 class, the percentage of the 1 class, and sigmoid function always gives the range from 0 to 1, right? So now if I say that how I will be able to divide, how I will be able to say it's a 0 or a 1, that's where this probabilistic function we are going to talk about, right? Probabilistic function, or I would say probabilistic factor, is simply nothing but if any data above 50%, then I'm going to classify it as a 0. If anything less than or equal to 50%, I'm going to classify it as a 1. Very simple, right? So yes, that is at high level the intuition behind this. And let's try to understand this sigmoid function, right? So if I want to write a sigmoid function, it's simply nothing but 1 divided by 1 plus e raised to the power t. And what is this t? T is nothing but our mx plus c. As you can see here, so how it is able to divide the data, right? If any data above this is going to be a plus, any data below this is going to be a negative, right? So now you can ask me that how will I be able to divide this data, right? So before that, we need to understand the assumptions of a logistic regression. The assumption of a logistic regression is that a data point should be linearly separable. When I say linearly separable, let's plot some of the data point here. Suppose say that I'm going to take some data points here and some of the data points over here, right? So now if I want to draw a line, if I want to divide these two data points, suppose say I'm going to call this as a positive and this is a negative. I cannot draw a line something like this. I cannot draw a line something like this, right? So they are not linearly separable. If I am able to, if I draw something, a line something like this, then what is going to happen? Let's take this example. So in this case, maybe some of my data points come over here. Let me put this. Okay, if I'm able to draw point something like this, so some of my data points will fall on a right side and some of the positive data points fall on a negative side. As you can see, these data points, right? So they are not a linearly separable. The linearly separable line should divide something like this, right? Any data above this line is a positive, any data below this line is a negative. So who is going to find this, right? So that's where we use a sigmoid function, and the sigmoid function graph looks something like this, similar to our S. And this is basically our sigmoid function, right? Now let's understand with some formula how it is going to behave. So why do we use a sigmoid function? As I already discussed, the sigmoid function's range is bounded between 0 and 1, right? It's between a 0 and 1. Thus, it's useful in calculating the probability for the logistic function, right? If anything above this, I'm going to call it as a positive. Anything below this, I'm going to call it as a negative. Its derivative is easy to calculate than other functions, which is useful during the gradient descent calculation, right? We have understood the gradient descent in other series. So you can go ahead and check the gradient descent. And it is a simple way of introducing a non-linearity to the model, right? Linearity means we know that what is the linearity in linear regression. Non-linearity means if the data points are not able to divide linearly, so it is able to introduce this non-linearity to the model. So that is the sigmoid function property, I would say, right? So let's see some points here. Let me delete this. And yeah, I can write a logistic function as below here. So e raised to the power mx plus c divided by 1 plus e raised to the power mx plus c, right? So now if you further look into the below formula here, so I will be able to write that function something like this: 1 divided by 1 plus e raised to the power minus mx plus c, right? So now if I can also write that function something like this, I'm going to call it as a 1, right? If I try to do some kind of a manipulation of that, I will be able to write this function, and I can try to manipulate that function something like this. And finally, the function looks like this. I'm going to call it as a 2, right? So if we divide 1 divided by 2, then my function, give me a second, looks something like this over here, right? So what logistic function is, in the logistic function, what it does, in order to get the probability, it is going to apply a log transformation, right? So we are going to apply a log transformation, and when we apply a log transformation, that will give a probability, right? Or maybe some number it is going to give depending upon the data basically. And how I'm going to make a prediction here, it's basically, as you can see, if anything above 0.5 equal or above 0.5, I'm going to classify it as a 1. If anything less than 0.5, I'm going to call it as a 0 class, right? If I want to predict any class here, I am just it is going to simply say that less than 0.5 assigned to 0 and greater than or equal to 0.5 is basically 1. 0.5 here is nothing but you can assume it's a 50%, right? It's a very simple intuition. Anything above 50% is a positive, or you can say a 0 class, and anything below this is a class 1. Right? That's this is the sigmoid function that we use in a logistic regression. This is going to help us to find the probability of any data point class, right? Based on the input features, it is going to give me a probability of a class, and based on the probability, I will be able to assign it either a 0 or a 1 based on the percentage here, right? So that's all in this video. Thank you for watching this video. See you in the next video. Keep learning.